and the main things which we are going to discuss, the questions only. Okay, so just don't hesitate to put up your questions in the class, and I will not take that much of time, and I will do it very speedily today. I will try to. Okay, so before the examination, right, we do some revision, right? So doubts, whatever there with you, you can directly put it up over here, right? So before starting, let me come up with a question quickly. That yes, the question number one for today is that a room is given to you. A room is given to you, and what is the length of the maximum? What is the length of the maximum longest pole which can be placed into the room? Okay, so the room is given with dimensions 12 meter, 9 meter and 8 meter. I've already put a shots of it, but yes, don't worry, I will explain it. So to solve this question, my dear friends, you need to understand, if the room dimension is given to you as 12 into 9 into 8, right, that means the length is given to you. This is length, this is breadth, this is height, right? So into that case, you need to understand that yes, if you will take two dimensions, this one length and breadth, then this will be looking like this, right? Length and breadth, this will be length, this will be breadth. So my dear friends, just remember, the diagonal of a rectangle is the greatest length which can be placed inside this plane figure, right? But we have our three-dimensional figure. This is a solid figure because this is a reflection of a cuboid, right? So this is the longest over here, this is the longest length which can be placed over here, which can be said for the rectangle ABCD as AC is the longest, right? AC is the longest, but this is a this is a room whose length and breadth is given, but my dear friend, this is also having certain height. So if it is a it is a cuboid, it is into the shape of a cuboid, the room will be looking like this. Okay, the room will be looking like this. So if you consider the maximum length which can maximum length of the pole which can be placed inside is nothing, but you can see this was for the rectangle. For the rectangle, this was the longest portion. Okay, but since it's an room, so the maximum length can be placed from here, from this corner. If you consider the rectangle length into breadth, so from this corner of A to the extreme corner, this one, so this will be like this, right? This is the extreme corner, and this will give you the longest length. This will be give you the longest length, right? As we already discussed, that yes, the diagonal of a plane figure is its longest length, right? So if you consider length and breadth, this is the longest length, right? But with this, you need to just assume this one to calculate again as per right angle, to calculate the length of this longest diagonal. Okay, so let me draw the figure like this again so that quickly we can explain it. Okay, this is the diagonal for a plane figure, and if this is a room like this, right, then definitely the longest diagonal will be starting from here, from the bottom, from the base of the room, right, from the floor of the room. This is the floor of the room where length is there, breadth is there, right? So from this point A, right, A B C D, and here E, F, G, H, right? If this is the room, then we can say that the longest pole which can be placed inside it is starting from A, that means from the floor, corner of the floor to the top of the ceiling. This is the longest diagonal which can be put into this room, right? So how to calculate it? I am quickly saying it. If length is given to you as 12, breadth is given to you as 9, then 12 into 9 will give you this diagonal. That means diagonal at the floor. So it will be nothing but root over of, this will be giving you nothing but root over of L square plus B square, that is by Pythagoras. Because just assume this is a 90-degree, it's a rectangle, right? Every face of a cuboid is a rectangle, right? If this is 90-degree, then the length of AC is nothing but root over of 12 square plus 9 square, right? And this will give you root over of 144 plus 81 225, and this is coming as 15 as the length of AC. And if the length of AC is calculated, this AC is known to you, right? Then again this will be forming a right angle over here. Okay, you can understand that from the diagonal AC, from the platform ABCD, AC is the diagonal. And considering this height, because height of this room is 8 meter, we have not considered this. So if this height is 8 meter, I mean to say C to F is 8 meter, then the longest diagonal is the blue one, right? This one, this is the longest diagonal. This is the longest diagonal. So this could be the length of the maximum pole which can be put inside the room, right? So it will be equal to, again the Pythagoras will be applied into this triangle, my dear friend, this triangle ACF, right? This is standing oblique like this. Okay, so the this is the perpendicular, right? And this will be the diagonal AC which we have considered is your, it will be like this, A to C, which we have considered and calculated as 15. Again this over here, a height is 8, and on the top we have F over here. I am just drawing a picture of this so that you can understand clearly, right? And from this A to F use your longest diagonal of this room, right? So AF is calculated as root over of 15 square, root over of 15 square. AF is considered as root over of AC square plus CF square. And what is AC? AC square is 15 square. And what is CF square? CF square is nothing but 8 square. So my dear friend, this is the length of the longest diagonal. Root over of 15 square plus 8 square. That means root over of 225 plus 64. 8 square is 64. So this will be giving you root over of 289. So our option is 17. So 17 meter is the length of the longest diagonal. This is your answer, my dear friend. So you can solve such questions. You can solve such questions very easily if you understand the basic concepts of a cuboid. Okay. We did, we can simply understand that in a rectangle, the longest side is its diagonal. Okay. But if it is a room, then definitely another rectangle will be placed over here. Okay, and this is the room, right? Then from this bottom to the corner of the top corner, diagonal length, this will give you the longest one, which we just calculated for this is the longest one. Now quickly coming to the second question for today, my dear friend. The second question which can take it for today, let us do some perimeter and area of the plane figures. Okay, area and area of the plane figures. So the question which we can take for today is that a triangle is given to you. The question number 2 for today. And my dear friends, you can put up your doubts over here very openly. Okay, this is an open session. A, B, C. It's given that B, C, A, right? And under it a triangle. In the given figure, triangle ABC is an equilateral triangle. That means this is 10, this is 10, this is 10, given to into the question. Now, from here, ABC is an equilateral triangle and the length of whose side is equal to 10 centimeter, and triangle DC is right angled at D and BD equal to 8 cm. So inside it a point D is there which is making a right triangle inside the equilateral triangle ABC, and this angle is 90 degree, right? This angle is given to you as 90 degree, my dear friend, right? Now the question is that if B to D is 8, if this is given to you as 8, right? Let me zoom a little. I think it's visible now, right? If B to D is 8, now find the area of the shaded region. This is the shaded region which is given to you. I have taken this question from area of plane figures, right? As we already did some solid figures, let us do some plane figures. Okay. So to find the area of the shaded region, what is the steps which you need to follow? I'll just say the steps only. Okay. You know the area of equilateral triangle. Okay, it's root 3 by 4 into side a square, right? So what we will do, root 3 by 4 into the side will be 10, so it will be 10 a square. This will give you the area of the triangle. So triangle area is root 3 by 4 into 100, right? From this triangle area, subtract the area of this triangle BDC. BDC, you will get the area of the shaded region, right? You will get the area of the shaded region. So my dear friends, how to calculate the area of the triangle BDC? How to calculate the area of the triangle BDC, right? To calculate the area of the triangle BDC, this is BDC, you know, this is given a right angle triangle, right? Then this is 10, the hypotenuse is 10 opposite to the 90 degree, this is 10. You are knowing BD, can to calculate CD, and if you know the CD and BD, then area of this triangle BDC, right angle triangle, is equal to half into base into height. So half into 8, and this this CD can be calculated as root over of 10 square, that is 100 minus 64. So this is coming as root over 36, which is 6, and area of the equilateral triangle which you already calculated. So from this subtract the area of this white triangle to get the shaded region, right? So in this way we can solve such question, my dear friends. So question number 3 which we can take for today, question number 3 is that find the length of a hypotenuse of an isosceles right angle triangle whose area is 200 centimeters square. So an isosceles right angle triangle, that means it's given that a right angle triangle is given to you, but it's isosceles, right? It's isosceles. That means if the triangle is given as isosceles, so what is the thing which is coming into your mind? Isosceles means two sides of a triangle are equal. So read the question very carefully. Okay. So that means if this is a right angle triangle, this is given to you. So this one of the angle will be 90 degree, and this will be a right angle triangle, and being an isosceles, you can say AB and BC are equal to each other. Why AB and BC is only equal? My dear friends, AB and BC are only equal because hypotenuse is the greatest side of a right angle triangle, right? This will be the greatest, right? This will be greater. So AC will be the longest side, the longer side, right? AC is the longer side, being hypotenuse, right? Now if this is the longest side, then definitely BC is not the longest. AB will not be the longest. Then which of the two sides could be equal for an isosceles right angle triangle? Only AB and BC could be equal. And this is your base, this is your base, and this is your perpendicular, right? Now from here, it's given that the length of the hypotenuse of a right angle triangle, find the length, this need to be calculated. So we need to calculate the length of the hypotenuse if the area of the triangle is 200 centimeters square, right? Area of the triangle is given to you as equal to 200 centimeter square. So my dear friends, if this is the question in front of you, it's given that area of the triangle is 200, right? And this is isosceles. So let us assume the base as x, then definitely perpendicular will also be equal to x, right? So into this case, 200 centimeter square will be equal to half into x base into height, right? And when you solve it, you will get the value of x. When you get the value of x, can you calculate the length of the hypotenuse? Right, we can quickly do it. Let us come to the question number 4. I hope you got the point, right? Question number 4, which you can take for today, is that each of the equal sides of an isosceles triangle measures 2 centimeter more than its height. Is given that each of the equal sides of an isosceles triangle measures 2 centimeter more than its height and the base of the triangle measures 12 centimeter. Find the area of the triangle. So I think we can do it. How? Each of the equal sides of an isosceles triangle measures 2 centimeter more than its height and the base of the triangle measures 12 centimeter. So my dear friends, to solve such questions, how to proceed? Let the height be h, right? Then we can say that if this is the isosceles triangle, it's not given that it's a right angle triangle, each of the equal sides of an isosceles triangle. So let us say maybe this is the isosceles triangle, maybe this is the isosceles triangle a b c. So let us say these are the equal sides AB and AC, right? And it's given that the base of an isosceles, it's given that each of the equal sides of an isosceles triangle measures 2 centimeter more than its height. So if the height of this isosceles triangle is this one, maybe AD, right? Then it's given that each of the equal sides of an isosceles triangle measures 2 centimeter more than its height. So if the height is h, if the height is h, this is given that equal sides is h plus 2, right? This is h plus 2 and this is also h plus 2 as per the question, right? If this is h plus 2 and this is h plus 2, why? Because being an isosceles, AB is equal to AC and its relation is given that from the height they are increased by 2. So this is, if the height is h, the length of AB and AC is h plus 2. Now, and the base of the triangle measures 12 centimeter and is given that this is given to as 12 centimeter, right? Now find the area of the triangle. My dear friends, to find the area of this triangle, if you know the length of the base and if you calculate h, then half into base into height, you get it. And you know that if this is h plus 2, this is h plus 2, so two equations will be formed over here. How? In triangle ADC and ADB, what will be done? In triangle ADC, let us assume the CD length is x, then BD will be 12 minus x, right? Now being a AD as altitude, this angle is 90 degree, right? So for this triangle, what we can do, apply the Pythagoras, then h plus 2 square will be equal to h square plus x square. So two variables will be there. One is h and one is x. From here you get equation in two variable. Again, from here you will get two equations. From here also, from this triangle also, you will get an equation with a variable h and x. How? Apply the Pythagoras over here, then we can say that h plus 2 square is equal to h square plus 12 minus x whole square. This is 12 minus x because base is given as 12, right? Then from here you get an equation into the form of h and x. From here you get an equation from h and x. So this will give you equation number 2 and this will give you equation number 1. Just solve to get h and x. If you get x, you calculate the h. If h is known to a you, then area of this triangle is equal to half into bc into h. If you are knowing h, then put up the value half into bc. Bc is 12. Put up the value of h over here and your answer will be there with you, right? So with this we can go to the next question very quickly, very quickly, very quickly. So the question number 5 for today. Question number 5 for today, my dear friends. Okay, so the question number 5 we can take for today is that I think these questions perimeters of plane figures, we did perimeter and area of plane figures done. Perimeter and area of plane figures we have did. Area of plane figures is completed, so we can just keep it as tick mark. Just remember few of the formulas. Yes, if a rectangle is given to you LB, this is the maximum length which can be put inside it. This is the diagonal of this triangle, right? And again, one more question was there. That was a good question. So these questions can be done again. After this plane figure, let me come up with the next topic quickly in between until I am finding the question. They just let us do one question from sector. Okay, a sector is given to you and another sector for the same triangle and third sector. Okay, you know all the angle at center is 360 degree. You need to find the area of the shaded region. These are the three shaded regions which are given to you. This is the second sector, shaded sector. This is the third shaded sector, right? It's given that into this question, this angle is given as 40 degree. This is given as 80 degree, and this is given as 60 degree, right? So if these three angles are given to you, right, and it's also given that radius of this circle is 7, then find the area of the shaded region. Then I think you can easily calculate it. How? We know the formula that area of the sector is theta by 360 into pi r square. I think you need to assume it, otherwise it will be difficult to solve this question, right? This is very simple formula, right? And because we are at the end of the session, it's very, I am assuming that you are already learned it, right? Now from here you can see three sectors are formed. Three sectors, one with angle 40, one is angle 60, one with angle 80. To area of the shaded region can be calculated very easy by area of the first sector. Just put up the value of theta equal to theta 1. Let us say this is theta 1, this is theta 2, and this is theta 3. So it will be theta by 360 into pi r square plus theta by 360 into pi r square plus theta 2 by 360 into pi r square. So just do take pi r square as common, and inside the bracket we have theta 1 by 360. Even 360 can be taken as common from here. Okay, it will be theta 1 plus theta 2 plus theta 3 And when you just add 40 plus 60, 100 plus 80, it will be equal to 180. So it will be equal to 180 by 360 into pi r square. So my dear friend, during the examination, don't abruptly go and find the area of first sector, then second sector, then third sector and add it. No, no, no. You can do these quick steps. Okay, see how the simplification can be made easier. You can see for all the three sectors, I have taken pi r square by 360 can be taken as common. So whatever which can be taken as common, just take it as a common. Otherwise, this will make your calculation tedious. Okay, so just take out the terms which can be taken as common, right? So here pi r square by 360 is lying in all the formula of the three sectors. So that's why under the bracket we are left with theta 1 plus theta 2 plus theta 3, which is coming as 40 plus 80, 120, 120 plus 60, which is coming as 180. Hi Tanmay, hi Khushi, hello, good morning. So quickly let us go to the question number 6 for today. Okay, question number 6. You can put up your doubts, my dear friends. Any doubt, let us try to solve it together. Okay, the question which I can take it for today: the side of an equilateral triangle is equal to the radius of a circle whose area is the area of the triangle is how much. Okay, the question is that the side of an equilateral triangle is equal to the radius of a circle. Okay, so the question is that if an equilateral triangle is given to you and side of this equilateral triangle is the radius of a circle, that means a circle is also given with a radius r, right? Now the question is that the side of an equilateral triangle is equal to the radius of a circle whose area is 154 centimeter square. So radius of a circle whose area is 154. So here is given that area of the circle is 154. If 154 is coming to you, then immediately something coming into your mind, that is area of a circle is pi r squared, isn't it? So just equate it with pi r square. You get the value of r from here. Whatever the value of r you are getting it, okay, you can put it over here. So now you are knowing the sides of the equilateral triangle. Now at this step, what is the next thing? Now they have asked into the question, what is the area of this equilateral triangle? So in such questions, a relation is given to you. Directly the side of the equilateral triangle is not given to you. Otherwise you can use the formula root 3 by 5, root 3 by 4 into side square to calculate the area of the equilateral triangle. But the side of the equilateral triangle is not given. A relation is given that this area, the side of the equilateral triangle is equal to the radius of this circle, and even the circle radius is not given to you. It's given the area of the circle. So my dear friends, you can use the formula to calculate the radius, and this radius can be used over here, and this can be found that the equilateral triangle side is evaluated over here because r is known, and that is equal to the side of this equilateral triangle, and this will give you the area of the equilateral triangle, my dear friends, right? Another question: the area of rhombus is 480 centimeter square. Question number 7 for today. We are doing the plane figures quickly. After that we will again look for some solid figures. Okay, the area of rhombus is 480. So rhombus, right, diagonals intersect at 90 degree. These things coming into your mind immediately, right? ABCD is a rhombus. It's given that area of this rhombus is equal to 480 centimeter square. So don't forget to write the units, my dear friends. We are quickly doing it, but if I am missing it, you should not miss it. Otherwise, marks will be deducted. Units should be written very properly. Okay, units should not be left. Marks will be deducted for this. Okay, so area unit will be cm square. Anyway, area of the rhombus is 480 centimeter square, and the length of one of its diagonal is 20 cm. So let us say this diagonal is given to you as 20 cm, right? And the question is that length of each side of the rhombus need to be calculated. Very good question, right? Now my dear friend, here you can see the area of a rhombus is equal to half into d1 into d2, right? If you are knowing one of the diagonal and you are knowing the area is equal to 480. Just equate it with half into d1 into d2. You are knowing one of the diagonal, just calculate the another diagonal. Let us say this one. So when you solve it, you get the value of d2. d2 equal to what? And you also know that diagonals of a rhombus bisect each other, right? So if this is 20, if this is 20, then this one will be 10 and this one will be 10. If O is the point of intersection, BD is given to you as 20, then DO is 10, BO is 10. Now, similarly, D2 is calculated AC. That means D2 is nothing but your second diagonal, AC, using this formula. And if this is calculated, you are knowing the length of this one also, AO, and you are knowing the length of CU also. So if you consider this triangle, definitely as the property of the rhombus, you know that diagonals of rhombus intersect each other at 90 degree. Then it's been asked that what is the length of this, what is the length of this diagonal, length of this rhombus, side of the rhombus. Okay, so if you are calculating OD from here, you are from here you are knowing that this is 20, then OD is how much? 10. This is known to you. From here AC is calculated and half of it is known to you, then that means AO is known to you, right? If you are knowing DO, if you are knowing AO and this angle is 90 degree, right, then definitely can to calculate AD. Apply Pythagoras, my dear friend, apply Pythagoras. Root over of OD square plus AO square, right? Anyway, so these questions can be solved. I know you all are smart enough to solve it. Let me tick mark this question that we have taken up. Right now, let me quickly go to the next topic. Area of the circle, sector and segment, we already did it. Now, coming to the solid figures now. Just a minute. Question number 7 is already done. Let us quickly go to the question number 8 for today. What is the question number 8 for today? The question number 8 which can be taken for today is that in the given figure semicircles A and OB, if the perimeter of the figure is 40 cm, find the area of the shaded region. A good question which I have found, okay, is that the figure is like this. So basically we need to find, there are two semicircles, okay. One is this semicircle with a radius this one, and another is a semicircle with a radius this one, right? Now it's given that APB and AQO are semicircles. It's given that it's A, P, B, APB are semicircle, and AQO, this is Q and this is O. APB and AQO. AQO. Both of these are semicircles given to you into the question. Now, my dear friends, these are the semicircles, and from here it's given that find the area of the shaded region if the perimeter of the figure is 40 cm. Now it's given that perimeter is equal to 40 cm. Now perimeter is given to 40 cm, find the shaded area. To solve such questions, my dear friend, just see very basic things. The basic things which we can consider for today for solving this question is that, yes, if the perimeter is 40 centimeter, that means the length from A to P, P to B, B to O, O to Q, Q to A. This is known to you, right? Perimeter is the length of the outer boundary of the given geometrical figure, my dear friends. So if perimeter is 40, we can write that 40 is equal to APB plus OB plus OQA. OQA, right? That means these three lengths need to be calculated. Now my dear friends, tell me, APB, if the radius of this circle, let us say the smaller circle is R. So from the figure you can see this will be equal to 2R, AO will be equal to 2R, and then OB will be also equal to 2R because this will be the center. If this is 2R, then instead of OB write 2R, right? APB is the circumference of the semicircle. So it will be equal to 2 pi R, 2 pi into R. R will be 2R, mind it. I am calculating for the bigger one, APB, right? So 2 pi into 2R whole divided by 2, because circumference of a circle is 2 pi r. If you are considering this one, right, this one, then definitely it is a circle, semicircle with a radius 2r. So it will be, that's why 2 pi r divided by 2, where r is equal to 2r over here for the bigger circle. So a length of APB is calculated. OB is nothing but your radius of the bigger circle. This is equal to 2r. And what is OQA? This is also a semicircle with a radius a small r. Okay, so this will be equal to 2 pi into r divided by 2, right? So this is equal to 40. My dear friends, only one variable over here, r. Calculate the value of r. If you calculate the value of r, then area of the shaded figure can be easily evaluated. How? Area of this shaded region will be equal to pi into r square, right? And for this shaded region, for the bottom, the bigger semicircle, it will be equal to pi into 2r whole square, right? So just add it and solve and get your answer, right? So we did 8 questions for today. Let us come quickly to the question number 9. So question number 9, which we can take for today, is that we did this question. Shaded figure we already did a lot. Let me take some questions from solid, I mean to say cylinder, cuboid and solid surface area of solids. Okay, so for the surface area of solids, let me take one question. A conical vessel is given to you where radius and height is given to you, and from it's emitted into a cylindrical vessel. Radius and height is given to you. To what height cylinder fill in cylindrical vessel to empty the liquid? So that means a conical vessel is given to you. Okay, from this conical vessel a point is there, so water is dropping like this, right? Water is dropping like this. Now this is going into a cylinder. Okay, so a cylinder is kept over here, right? The cylinder is kept over here. The question is that this is a cylinder and this is a cone. Okay, the question is that conical vessel of radius, that means for this cone radius is given to you as 12 cm, height of this cone is given to you as 50 cm, and this is filled up with water, with certain liquid. Okay, now this liquid is allowed to drop from this end point, and this is an opening, and this is falling into a cylinder. Now question is that to what height liquid fill in cylinder? To what height? This height need to be evaluated. To what height the liquid fill into the cylinder? Let us say this is the height of the liquid which is filled into the cylinder when the entire liquid is poured out from this opening and coming to the cylinder, and this become vacant, right? So that means this liquid is coming over here, right? And this liquid is coming over here through this opening. Then what we will do, my dear friends, just equate the volume of this cone. What is the volume of the cone? 1 by 3 pi r square h, right? This is the liquid content. This is the volume of the liquid, isn't it? This is the volume of the liquid which is inside the cone. Now this is coming to here. Now for the cylinder is given that radius is 10 centimeter. This is given that r equal to 10. And what is the volume of a cylinder? Volume of the cylinder, it's very easy. Volume of the cylinder is pi r square h. So whatever the water there into the cone, and this is coming into the cylinder, and this is filling up to a certain height only. This is height is h. Mind it. This height is h. Now the volume of the water content, water or the liquid, let me write it liquid, the liquid which is kept over here from cone to, which is transferred from cone to cylinder, transfer from cone to cylinder, is equal to the volume of the liquid content into the cone. Volume of the liquid content into the cone equal to, just equate it with the volume of the liquid which is transferred to the, from here to here, from here to here, right? So simply put, 1 by 3, let me write it like this. If the volume of the cone is known to you, then liquid in cone is equal to 1 by 3 pi into r square, that is 12 square, into h, which is 50. This is the volume of the liquid, and this is equal to, volume of the liquid which is transferred into the cylinder. So this is transferred till this level only, right? So that means the volume of this liquid will be equal, which is transferred from here. This is the liquid volume, right? 1 by 3 pi r square h, which is kept into the cone, and that is equal to cylinder's volume where the liquid is filled till height h. Just see this height h, right? So this will be equal to pi r square h, right? Pi, cylinder volume is pi r square h. So this is coming as pi into r. R is given to you as 10 over here. So pi into 10 square into h. My dear friends, the question was that till what height the cylinder will fill. The question was that what is the value of h to which the liquid will fill into the cylinder. So when you just solve it, you can see pi will be cancelled out. You can do the calculations. This is a constant, this is a constant, this is a constant. Only h is the variable. Just solve to get the value of h, and this is your answer, that till this much of height the liquid is filled into the cylinder, my dear friends. This is your answer. This is your answer, right? Thank you so much. Quickly coming to the 10th question for today. A vessel into the form of a hemispherical bowl mounted by a hollow cylinder. So the vessel is like this. The vessel is like this. Let me show you. The question number 10 for today is that a vessel is like this, a vessel into the form of hemispherical bowl. So a bowl is given to you. This is a bowl. Bowl, that means a hemisphere is coming into your mind. But we are dealing the solid figures, right? So this will be a hemisphere, not semicircle. Okay, this is three-dimensional. So from this vessel, bowl mounted by a hollow cylinder. So above it, a hollow cylinder is kept. Okay, like this, right? And this will be the bowl. So definitely like this. The question is that a vessel into the form of hemispherical bowl mounted by a hollow cylinder, the diameter of the hemisphere is 14 cm. Diameter is 14 cm definitely. Just when you are going to solve the question, make sure, my dear friends, make sure that when the when the diameter is given to you, don't forget to convert it into radius, because radius is diameter by 2, and diameter given over here for the hemispherical ball is 14 centimeters. So radius will be 14 by 2, which is 7. Many times people do this mistake into the examination, that you are directly putting the taking up the diameter figure. Okay, so don't do that mistake. Okay, from here, just radius of the ball is calculated, right? Now, and the total height of the vessel is 13 cm. So that means the height of the vessel from this point to this point is given to you as 13 cm. This is given to you as 13 centimeter. Now, my dear friend, the question is that find the total, the capacity of the vessel. So you can understand the concept that if the radius of this hemispherical ball is 7, then definitely the height of the ball will also equal to the radius. This will also be equal to 7, isn't it? If you are knowing the r value for this, you can calculate the volume of this hemispherical ball, 2 by 3 pi r cube, right? 2 by 3 pi r cube, right? Now you are knowing the value of the volume, which can be kept inside the bowl. Now its question is that the capacity of the vessel, but the portion of the liquid which is kept inside this cylindrical portion is not evaluated. Okay, so to evaluate this, you just use the formula pi r square h. R will be same because this is just mounted, cylinder is just mounted above the bowl, right? So the h will be the height will is still not known to you, but radius will be same. So r will be same, 7, and height will be given that the for the entire one the height is 13. So definitely 13 minus this 7 will give you 6. So height of the cylindrical portion from here to here is nothing but 6. Why? Because 13 is the total height. 13 minus this radius, the height of the bowl, right? 13 minus 7 is 6, right? So pi r square into 6. This will give you the volume of the volume content of this cylinder. Just solve it and then add to get the total content capacity of the vessel. What is the inner surface area of the vessel? So inner surface area of the vessel, my dear friends, you know, 2 pi RH 2 pi RH is the curved surface area of a cylinder, right? We know it. Now, right now, if 2 pi RH is the curved surface area of the cylinder, then for the cylinder it will be done considering H as 6. 2 pi RH, you are knowing all the figures. So the surface area for this one will be equal to, surface area for this figure will be equal to 2 pi RH for this cylinder, right? Plus for this one, it becomes 2 pi r square. How 2 pi r square? Because for a sphere is 4 pi r square. So for a hemisphere is 2 pi r square. So 2 pi r square. You are knowing all the figures. Put up the figures and solve it and get the total surface area of this figure, right? So in this way we have solved question number 10 also, my dear friends. Now quickly coming to question number 11 now. Maybe we have certain few time with us. Any doubt you can put up into the comment box, my dear friends. Tanmay, Khushi, hellos, Sandeep. So anyway, the question which can be taken for the solve from the volume of surface area of solids, because today I'm going to finish the mensuration and thereafter we'll come up with next trigonometry or coordinate any other important topic. Okay, because the examination is coming in just into the next week, even we have not 1 week with us, right? A solid into the shape, oh, let me take it up from the exercises. 1 minute, my dear friends, 1 minute, give me 1 minute. Quickly, we let us do the questions very quickly because we are running out of time. Question is that the surface area of a sphere is 2464 if its radius be doubled. So my dear friend, you need to remember all the important formula. It's given that the surface area of a sphere is 2464, and this is a sphere, right? So when a sphere is coming into your mind, you should immediately remember, yes, if this is an sphere, then surface area is 4 pi r square, right? Equate it with 2464, which is given to you. You get the value of r. You evaluate the value of r equal to what from here, right? You just solve it. Now the question is that if its radius be doubled, what will be the surface area of the new sphere, right? So if r is calculated from here, that is simply 2464 divided by 4 pi root over, you will get the value of r. And the question is that when the radius is doubled, you will have a bigger sphere, right? And radius will be equal to 2 times the radius of this sphere. Here we have r, right? Then what is the new surface area? Definitely, my dear friends, surface area formula will not change. It will be equal to 4 pi r square. But here r will be equal to 2r. This will be capital R equal to 2r. So put up the value of 2r over here and evaluate. You will get your answer, my dear friend. Okay, quickly coming to the question number 12, my dear friends. Question number 12 is that a solid is into the shape of a cone mounted by a hemisphere. So any mounting questions you can do it, my dear friends. Okay, it's very easy. It's very easy. From a cubical piece of wood of side 21 centimeter, 21 centimeter, a hemisphere is carved out. Okay, let us take up this question. It's already come into the CBSE earlier. Okay, from a cubical piece of wood, that means a cubical wood is given to you, right? So you know the shape of a cube anyway. So this is a solid wood where from 8 cubical piece of wood of side 21 centimeter. This is 21 centimeter, right? A hemisphere is carved out in such a way that the diameter of the hemisphere is equal to the side of the cubical piece. So here it's given that from here a hemisphere is carved out here, right? So hemisphere is carved out, that means the radius of the hemisphere can be evaluated, right? And that will be equal to, if you consider this one, the edge of 21, right? Then the radius, this will also be equal to 21, and half of this will be your radius. Okay, so for this, if you consider 21 by 2 as the radius of this carved hemisphere, right? 21 by 2 as the radius, then find the surface area of the volume of the remaining piece, right? So hemisphere is carved out from cube. So cube is given to you, right? From it, subtract the volume of the hemisphere, right? You will get the total volume, remaining volume. Find the surface area and volume of the remaining piece. So volume can be calculated like this, and what is the remaining piece surface area? So my dear friends, total surface area of the cube, total surface area of the cube minus area of the top of the hemispherical part plus curved surface area of the hemisphere will give you the total surface area. Volume is very easy. Volume of the cube minus volume of the hemisphere, you can easily calculate it. This will give you the volume, right? For the surface area, if you are going to the find the surface area after carving out this hemisphere, what is the total surface area? This will be the total surface area of the cube. That is how much? A square, a square, a square, a square, a square. That is 6 into a square, 6 into 21 a square. This is the total surface area of the cube. This is the total surface area of the cube, right? This is the cube total surface area, right? Minus area of the top of the hemisphere, because hemisphere is just a circle shape is there over here into the top, because this is carved out, this is cut and bring out from the solid shape, from the solid cubical block. So minus the area of the top of the hemispherical part, that is equal to pi r square, because this will be a circle, you can see here this will be a circle, and if this circle is carved out, this will be subtracted. We are going to find out the remaining area from this hemisphere. This circle is carved out, so that means you can see a hollow over here. Okay, from here you can see a hollow piece, you are able to put your hands inside it, right? So this circular area through which you are crossing, that will be subtracted, right? Plus curved surface area of the hemisphere. For the full sphere it's 4 pi r square, so for the hemisphere it's 2 pi r square. So just add 2 pi r square for the hemisphere area, okay, with the curved portion which you can just able to touch it from your hands when you just put your hands inside the cube, right? This portion which I am saying, this portion which you are able to touch, this will be equal to the curved surface area of the hemisphere, 2 pi r square. Just solve it and get the total surface area of the remaining figure. So my dear friends, with these 12 questions, I think we can wind up today's session, because quickly we did it. And any question from your side, I always welcome you. Let us go through the chat once, okay? Because I know today we will be finishing the mensuration chapter. You can go through these two. There are two videos for mensurations. You can, whenever you are having a spare time, you are doing your studies, you find some little much in casual period, you just go through those two videos, okay, of live sessions. I've tried to cover some important questions. It's not more than 20, okay. You can go through this, okay. And with this we can wind up today's session, right? One more question which we can just discuss over here into the class before closing is that when two spheres of some metal weighs this much of kg and this much of kg, the radius of the smaller is this one, the two spheres are melted to form a single, find the diameter of the, right? So you should, when two spheres are given to you, when two solid figures are given to you and it's melted, whenever the condition of melting is given to you, mind it, whenever condition of melting is given to you, it clearly shows that you need to consider the volume of that geometrical shape, whatever it be. Volume only need to be considered, okay, nothing more than that, because whenever you are melting, the solid content is transformed from one shape to another, okay, but the volume will be same, right? So volume need to be same, that you need to remember, right? Now when the melting is done, volume will be constant, whatever be the geometrical shape it is converting from a sphere to solid, cylinder from a sphere to cone to cylinder to sphere, like this, okay. So any solid figure is given to you and which is melted, that read out the question, whenever the melting is given, think directly volume, not area. This is the step which you need to remember, right? So when two figures are melted, two solid figures are melted, A and B, and giving rise to third figure C, then calculate the volume of A, calculate the volume of B. Maybe some radius or height is missing into the third figure, just equate it and get it. Okay, in this way we can find the missing portion. Whenever the melting question is there, use the volume only, right? And you can see for the two figures, when two solid figures are melted to form a third one, like A and B is melted to form a C, then you can see you must have understood into the question that you have that much of experience or practice till now, that you get that yes, some parameters, all the parameters of A, B, C are given to you except the missing one. And in the question, it has been always asked to find that missing parameter. Okay. So in this way, we can solve this question, my dear friends. Thank you so much for watching. Take care. Bye bye. Happy learning. Bye bye. See you into the next class. With this, we are winding up the mensuration topic for examination. Before the examination, all the best. For this, we can close the mensuration topic for today, right? Now I will come up with a different topic, maybe trigonometry or coordinate, whatever we wish. But yes, today we are closing this mensuration before the examination. All the best for all the questions of mensuration, my dear friend. Thank you so much for watching. Take care. Bye bye. Happy learning.